20, completing the square and differential equation. Everybody knows how to complete the square. Our first question in middle school is to simplify this to obtain the final result. Everybody knows that the sum, the solution is this. I don't have to explain in detail about the derivation, but the most important part I'd like to tell you is it is very closely related to the simplification of the second order differential equation. And the method we use to complete the square is keep the leading piece, but we have a subleading power. This is the highest power is x squared, and this is the second to highest. Inclusion of this term makes your solution complicated. It's very dirty. I don't like it. You can always kill this guy by what? That is my question. I'd like to convert this equation into these three cases. X squared equals 0, x squared equals 1, and x squared equals minus 1. I'd like to re-express this one, this dirty equation in the very simple equation, and even middle school or high school student can solve this equation without any somebody's help. You know, what's that? Elementary school student says this is the only solution? No, plus minus 1. Middle school student cannot tell you the answer, but high school student knows what this is, plus minus I. How can you tell them? How can they tell you the answer? That is the factorization. Multiplication of two numbers is 0, then it is equivalent A equals 0 or B equals 0. That means it is equivalent A equals B equals 0, or A equals 0 and B is not equal to 0, A is not equal to 0, and B equals 0. Everybody knows this. Therefore, if it is 0, at least one factor should be 0. That is the most important reason why we factorize the polynomial into this kind of the linear functions, product of linear functions. So product equals 0, then that is equivalent to any at least a single factor of this factorized formula must be 0. Okay. So we'd like to make use of this idea to solve the second or the most general second order differential equation. So I believe everybody knows what this answer is, how to derive this answer is. How? By completing the square. Completing the square. The origin of this completing the square is a binomial theorem. Why? A plus b squared equals a squared plus 2ab plus b squared. What you have done is we'd like to remove this. I don't like this. What's that? That a squared plus b squared sorry. a squared plus b, a plus b squared always includes this crossing term, product of a and b in it. So a plus b squared minus b squared equals a squared plus 2ab. So convert this one into this is called the completing the square. So what happens if I have x cubed? Use the same method. A plus b cubed minus b cubed. I know how to expand using Pascal's triangle. How? A plus b cubed, a cubed, 3a squared b, 3ab squared, and b cubed. Now we know a plus b cubed minus b cubed equals a cubed plus 3a squared b plus 3ab squared. So using this manner, I can remove both of them. However, in general, these two power, the coefficient do not have to be the same. So I would rather use this one minus b cubed and minus 3ab squared equals this kind of way. In this manner, this is the advanced formula for reducing the cubic formula, excluding square piece, keeping this a cube only, and the subleading term can disappear by using this way. Have you ever heard about the fundamental theorem of algebra? That is that any polynomial function, for example, x to the n, blah, 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 equals 0. How many solutions are there? There are n solutions. What kind of number are there? These numbers are all complex numbers. If there are even solutions that they are all in general complex numbers. How can you say they are complex numbers? We can reduce all of the higher order pieces using generalized completing the square. If you have x squared, 2x plus something, or 3x plus something, then, for example, this kind of thing, I can make it square and I can remove this guy and so on. So it becomes a quadratic equation. However, using this manner, I can reduce the order one by one by mathematical induction. In such a manner, finally, at the end of the day, you will find n solutions. This is not mathematics class, so let me go ahead. Our problem is this: damped harmonic oscillator. I don't like this, just like I don't like this. I don't like this. How can I do that? I have made use of completing the square. What should I do to remove this guy? This is possible. I can remove this first order derivative that originates from the damping term, the force, F equals ma. F equals ma. This guy is just ma equals minus kx minus bx dot. This is the spring force opposite to the displacement from the equilibrium position. This is damping force that is opposite to the velocity with the strength damping coefficient B. So because of this, solving the second order differential equation is rather complicated. But we know how to solve this kind of simple differential equation because we know how to solve for the simple harmonic oscillator. In most cases, they don't tell you in detail about removing this guy, but you already know very well about completing the square to remove the first order term. That is a very serious one. If you learn in middle school that you must be able to extend that idea to remove this guy with the same idea to simplify your problem, if you're not stupid. Okay, this is what I'd like to tell you about. Why don't we rescale this one by factoring out the function? This is the reason why we keep learning E. This is a very, very nice tool to deal with the differential equation. Differential equation originates from equation of motion. If you want to understand the nature, you need to construct the equation of motion, and happen to be the equation of motion is found to be differential equation, and solution of the differential equation is very easy to find once you know the law of exponent. Okay, it is simple algebra exponential. Why? Let me tell you. You take the derivative and apply Leibniz rule. Who is Leibniz? You keep using Leibniz rule. Leibniz introduced, not Newton, but Leibniz introduced d and integral. You keep borrowing his idea, his physicist idea. Okay, Leibniz generalized the binomial theorem to the derivative. And this is a binomial coefficients and number of derivatives applied to two factors. Using this idea, we can compute the first order derivative of x once we rescale the exponential function out of it. Take the derivative. Exponential function is a very simple function. It gives rise to a simple number. Exponential's derivative is itself, but what I'd like to do is multiply lambda. The multiplying one will give, for example, this one, if I am not able to compute, attach lambda and lambda. This is something like dy, ey, lambda. This is e to the y, lambda. What was e to the y? That is e to the lambda x. Okay, so a kind of substitution. It gives a lambda factor only. If you take the second order derivative, you will get additional pieces. These 2 and 1 originate from binomial coefficient. Who found it? Leibniz. Substitute them and reorganize the computation. Then tedious calculation will give you a constraint. You can remove the first order term by choosing lambda in this value, with this value. It is looks complicated, but just like completing the square, you have removed this dirty term anymore. You don't need this one anymore. So this equation you were supposed to solve, but it has been reduced into a factorized form, and what you need to solve is this, not this. It is stupid to solve this one directly. It is very clever to reduce this problem into a very simple form. Once you find this, you can always rescale these into three kind of cases. High school student can solve this one. Perhaps freshmen can solve this one. What is that? That's our next problem.